Today is March 21st. I almost said 31st. No. 3/21. Happy spring! So, when we last left our stoichiometry heroes, we had said that there were 4 different kinds of stoichiometry problems that we were going to do, and that, number 1 is by far the easiest. It's a one-step solve, all the way up to number 4, which is a multi-step solve. And I'm going to give you a graphic, an image. It's sort of a visual mnemonic to help you remember something. So you remember GMA, and you remember that if we're going from grams to atoms or molecules, we always have to go through moles. This applies for stoichiometry problems as well. So anytime that we're going to do anything with mass, with grams, we have to go through moles. Anytime we're going to do something with molecules, we have to go through moles. So we always have to incorporate those mole ratios. And we talked about finding mole ratios. You practiced finding mole ratios. And so we might as well just get started. So we'll start off with number 1, a given and unknown, both in moles. Okay, do you remember what this reaction was called? It's the flaming hot molten metal, 16,000 degrees Fahrenheit. Used it to weld rails out west. Okay, it's a thermite reaction. So you take basically powdered rust, iron oxide, mix it with powdered aluminum, light the whole thing off, typically with a magnesium fuse, and what you get out of it is aluminum oxide and pure molten iron. Pretty handy if you're going to weld rails out in the middle of nowhere. So here's the question that I'm going to give you. Okay, so how many moles of aluminum are required to produce 16 moles of iron according to the reaction above? What's the very first thing that we have to do? So we're going to solve all these stoichiometry problems using factor labels. And whenever you do a factor label, you start off with the first box containing your what? Your given. Okay, so what's the given in this problem? Where do you have a quantity of something that's given to you in that problem? We have 16 moles of iron, and that is, in fact, our given. So we start off our factor label with 16 moles of iron, and now we have to find a conversion factor, because what we want to know is how many moles of aluminum are required. So where do we get our conversion factor? What kind of ratios did you practice? Mole ratios. So we're looking for a mole ratio between the 2 chemicals that are involved here. And those are aluminum and iron. So we're looking at aluminum to iron. So we know that it's 2 moles of aluminum for every 3 moles of iron. The question is, what goes where? This is reaction stoichiometry because we're looking at how much of X do we need to produce Y, or how much of Y can we produce with this much of X, or how much of X will react with this much of Y. You get the picture. We're using a mole ratio, and we get that directly from the balanced equation. So the question being, what goes where? If you think back to all the stoichiometry you've done, units and chemical have to cancel. So what units, what chemical go on the bottom? Moles of iron. Cool. Moles, Fe, and we can get rid of this stupid circle. Okay, so what units and chemical go on the top? Moles of aluminum, what we want to end up in. And now we just take the coefficients from the balanced chemical equation and put them in. we get a number for moles of aluminum that are required. Calculators, go. Okay, you got a raw number? 10.666667. How many sig figs do we have here? 2. Because we're going from the given. We're not, the mole ratio does not count against you for sig figs. So your sig figs are derived from your given. We have 2 sig figs, so your final answer for this would be 11 moles of aluminum. So if you want to manufacture 16 moles of iron using this reaction, you're going to need to put 11 moles of aluminum in. Okay? Questions, comments, concerns? These are, I mean, the mole to mole are ridiculously simple. One step. Do you want to do any more mole to mole? Okay. Okay, we'll do one more. Okay. How many moles of aluminum oxide will be produced if 1.75 moles of iron oxide are reacted according to the equation above? So in this case, aluminum oxide is kind of like a byproduct for this reaction. Nobody's interested in getting aluminum oxide out of this. That's not what you're going for. You're going for molten iron, because this is, remember, used basically to weld stuff or to burn pumpkins. Okay, so it's a stoichiometry problem. It's a factor label. What do we start with? Given. What's our given? 1.75 moles of what? Of iron oxide. And remember how I said when we started doing stoichiometry, you need to put in the units and the chemical because they won't always all be the same? This is that moment. So you have to put in units and chemical. Okay, what units and what chemical go down below to cancel? Moles of iron oxide. And what units and what chemical go up on top to end up in? Moles of aluminum oxide. Okay. Now we need to figure out what numbers we're going to put in there. And to do that, we have to go to the balanced chemical equation. So where are we getting our numbers for our ratio? Okay, what number goes on top? 1. What number goes on the bottom? 3. Okay, get a raw answer. Okay, you've got a raw answer. It probably looks an awful lot like my raw answer. How many sig figs do we get? 3. So our final recorded answer for this would be 0.583 moles of Al2O3. Okay? Like I said, these are really simple, which means, of course, always that we're going to now complicate it. Okay, so we're sticking with thermite. What mass of aluminum, sorry for the messy writing there, is needed to produce 8 moles of iron according to the equation above? I guess I made that one fairly simple because they're both straight up elements. So what do you start your factor label with? Given, always. 8 moles of iron. Okay. Now, what we want to end up in are grams of aluminum. So our next step, we can't ever go straight from moles of X to grams of Y. We always have to go through moles. So what units, what chemical go in the next box to cancel? Moles of iron. Yeah, down and below to cancel. Oops. Moles iron. What units, what chemical go above? So we want to work our way towards grams of aluminum. To do that, we'll have to get into moles of aluminum. You always have to have the mole ratio as the center of your factor label, basically. So this is going to be moles of aluminum. And we need to get the numbers from the balanced chemical equation. We have a 2 there and a 3 there. So we have 2 moles of aluminum for every 3 moles of iron. Now, what units, what chemical go in that bottom on the final box to cancel? Moles of aluminum. And how do we get from moles to grams? What units, what chemical do we need to have on the top to get into? We're at the last step. We're ready to take the leap over into whatever units and chemical we want. So that last box is going to be grams of aluminum. Now, where do we get a relationship between grams and moles? The periodic table! Okay, what numbers go where in that last box? Pardon? 1 goes with moles, and aluminum, 26.98. 26.98 grams of aluminum in 1 mole of aluminum. So now you just need to plug it in. Okay. Do you have a raw number yet? Yep. 143.89333, on and on and on. How many sig figs do we have? 1. That was bad planning on my part. So we've got 1 sig fig. What would this answer be? 1 sig fig. 100 grams. Terribly imprecise. But that's what we're left to work with because the person who wrote the question did a lousy job of making sure that the measurement you were given had a high number of sig figs. That'd be me. Okay. Let's do one more moles to mass. Okay, so and let's make that 11.0. If 11.0 moles of iron oxide is reacted according to the equation above, what mass of aluminum oxide will be produced? Again, remember the aluminum oxide is kind of our byproduct. So what do we start with? As always, given. So 11.0 moles of FeO. What units, what chemical? Bottom in the next box. So we have moles of iron oxide in the bottom in the next space. What's going to be in the next space on the top? We know we have to go moles to moles. We have to have a mole ratio here. So what's the other chemical we're interested in? Aluminum oxide. So here we're going to have moles of Al2O3. And now we need to put in our mole ratio, which we're going to get from our balanced chemical equation. Okay. So for every 3 moles of iron oxide that's reacted, we generate 1 mole of aluminum oxide as a byproduct. What units and chemical will go in the next space on the bottom? Yep, because it's got to cancel. Moles of Al2O3. What units and chemical will go in the top? Grams of aluminum oxide. Now we just have one problem. Where do we get our numbers here? We need to do some math. I'm getting 101.96 grams. Okay, so 101.96 grams of aluminum oxide and 1 mole of aluminum oxide. So now it's just down to running your factor label. Okay, do you have a raw answer? When you do, you can compare it. I've written my raw answer up here already. 373.85333. How many sig figs do we have? 3. So our final answer with sig figs will be what? 374 grams of aluminum oxide. We have to remember that we're saving at this position, but we're rounding that one based on what comes after it. So 374 grams of aluminum oxide. Okay. Given 450.0 grams of aluminum and unlimited iron oxide, how many moles of pure iron could you produce according to the reaction shown here? So we're going to start off with our given as always, and what's our given here? Yep. 450.0 grams of aluminum is our given. Okay. What units, what chemical go in the next space on the bottom? Units and chemical have to cancel. That's the easy way to think about how you're going to start off. Grams of aluminum. Now the harder part, I think, is what units and what chemical are going to go above that. Because what we need to think about is what we're working towards ending up in. So what are we working towards ending up in? We want to end up in moles of iron. And aside from that, we just know that we always have to go through a mole ratio. So how do we convert from grams into moles? We're going to have to put moles of aluminum up here. Okay. What numbers will we be filling into those blanks? Well, there's only one number that goes in front of moles unless it's a given. What's that? 1. And what's the mass of aluminum? 26.98. Okay. So now what units, what chemical go in the next space? Moles of aluminum. And the final units in chemical on the top in the final space will be moles of iron, just what we want to end up in. Okay, we're going to get our mole ratios from here. And we have 3 moles of iron produced for every 2 moles of aluminum that react. So now you're ready to go ahead and calculate. Okay, when you have a raw number, you can compare it to what I've got. I wrote my raw number up here. Do you have a raw number similar? 50.03706449. Nope, I screwed that up. Hold on. I screwed that up. Let me get rid of that raw answer. Okay, 25.0185325. Sound more like it? Okay. How many sig figs do we have? 4. So we're looking at this. So our final answer is going to come to here but be rounded based on that. Our final answer would be 25.02 moles of iron. Okay. So the big thing to remember on any of these is that your mole ratio, let me highlight that in a different color, your mole ratio is always going to occur with, when you're doing moles to mass or mass to moles, your mole ratio is going to occur either at the end of the factor label or right there in sort of the first box that you've filled in. But in every single one of these, you're going to find a mole ratio. In the mole to mole, that's pretty much all the problem is your mole ratio. Okay, let's do, nope, wrong. Okay. So we're still dealing with thermite. How many grams of iron 2 oxide are required to fully react with 325 grams of aluminum? So we have compared reactants and products, products and reactants. This is a little bit different, though it's really not, because you're comparing two of the reactants. How many grams of this do you need if you want to fully react this many grams of the other thing? It's really the same in that you're just going through the steps. So what do we always start off with? You could all say it together. Our given. And there was great rejoicing. 325.0 grams of aluminum. So what units, what chemical? Bottom, next space. Grams of aluminum. What units, what chemical on top of that? Moles of aluminum. Because we know we have to work our way towards our mole ratio. What numbers are we going to put in here? Yep. 26.98 grams is 1 mole of aluminum. Now, we're ready for what's always the star of the show. What units, what chemical go in the next box on the bottom? We're going to put in moles of aluminum, and we want to end up in grams of FeO. So what mole ratio are we looking for? The mole ratio between aluminum and iron 2 oxide. So we're going to use moles of iron 2 oxide, and I'll get rid of my silly circle here. And what numbers am I going to put in here? Yep. So for every 3 moles of aluminum oxide, we can react 2 moles of aluminum. Okay, last box. What units, what chemical go on the bottom? Moles of iron oxide, yep. And what units and what chemical are going to go on that last top piece? Yeah, whatever we want to end up in, grams of iron 2 oxide. Okay, now we just need to know how many grams of iron 2 oxide there are in 1 mole of iron 2 oxide. So Fe is 55.85, O is 16, add them up. 71.85 grams of iron oxide and 1 mole of iron oxide. Now you just need to do the factor label. Okay, when you get a raw number, does it look an awful lot like this? You have a raw answer that looks a lot like that? Okay. How many sig figs do we have? 4. So we're going to keep this digit and round based on that one. Our final answer would be 1,298 grams of iron oxide. Okay. I'm going to turn you loose in the time you've got to do some practice in the chapter review. Tomorrow what I think we'll do is I'll let you check answers on those when you come in, and then we'll see where you're at. We may or may not do a FIP quiz tomorrow because we sort of absorbed a lot today. So let me give you the numbers from the chapter review, and then you can just work.